Okay, Rolle's theorem. So, the Rolle's theorem gives conditions that guarantee the existence of an extreme value in the interior of a closed interval. So an extreme value is a maximum or a minimum, and in section 3.1 for the extreme value theorem, it states that a continuous function on a closed interval must have both a minimum and a maximum on the interval. However, both of these values can occur at the endpoints, since it is a closed interval. So in Rolle's theorem, it gives conditions that guarantee the existence of an extreme value in the interior of a closed interval. So that means that the extreme value, the maximum or the minimum, cannot be on the endpoint. It must be somewhere within the interval. So Rolle's theorem states, let f be continuous on the closed interval ab and differentiable on the open interval ab. If f of a is equal to f of b, then there is at least one number c in AB such that f prime of c is equal to 0. So basically it's saying that in the closed interval, f has to be continuous and it has to be differentiable on the open interval. So it can't have any vertical tangents, it can't have any sharp curves or turns, and it must be continuous. Then there is at least one number c in AB such that f prime of c is equal to 0. So that's saying that the slope of a point c in A and B must be like a horizontal tangent. And that's just saying there has to be at least one, so there could be more than one. Okay, so if we look down, so basically, in these two pictures, in these two graphs, in the first one, f is continuous on the closed interval a and b and differentiable on a and b, on the open interval a and b, because there's no vertical tangents, there's no sharp turns and curves, and because it's continuous, so it's differentiable. And the value at x equals a and x equals b are equal, and they equal d, so the Rolle's theorem can apply here. So then there has to be at least one number c in this interval where the derivative of it is equal to 0, and there is, and that is at c right here. And this is the relative maximum, which from the previous unit or chapter, relative maximum is open interval. So the Rolle's theorem is applied here. Now, on this graph B, f is continuous on the closed interval a and b, but it is not differentiable on the open interval from a to b because there is a sharp turn and curve. So this is still a relative maximum at x equals c, but the Rolle's theorem does not apply because it does not meet, because it is not differentiable on the open interval, because there's a sharp turn or curve. So the Rolle's theorem does not apply. Okay, so let's look at a couple examples. We'll start with this one. If I can get it in a shot. Okay, so find the two integers of f of x is equal to x squared minus 3x plus 2, and show that f prime of x is equal to 0 at some point between the two x intercepts. So first, you have to find the two intercepts of the function. So you have to set the equation equal to 0 because those are like the zeros or the x-intercepts. And for x-intercepts, the y is equal to 0. So 0 is equal to x squared plus 3x, oh my bad, minus 3x plus 2. And then you factor, so you get x minus 2, x minus 1. So x is equal to 2 and 1. And these these 2 points are the zeros. So y is equal to 0 when x is equal to 2 and when x is equal to 1. So those are our 2 intercepts. And then you need to show that the derivative of these 2 values, the derivative is equal to 0 at some point between these 2 values. So remember, it cannot include these 2 values. So then we need to take the derivative of this equation. So the derivative of fx is equal to the derivative. Use implicit differentiation, minus 3x is 2. So f prime of x is equal to 2x minus 3. So you need to show that the derivative is equal to 0. So you set this to equal to 0. 2x minus 3. You get x is equal to 3 halves. So 3 halves is in between the 2 x-intercepts, and its tangent, the line tangent to it, is equal to 0. It is a horizontal tangent. You can't see my work. There it is. It is a horizontal tangent at this point, and it is within the interval 1 to 2. So these are the intercepts. And then this is the point. Yeah. Okay, so let's try one more example. Let f of x equal x to the 4th minus 2x squared. Find all values of c in the interval -2, 2, such that f prime of c is equal to 0. Okay, so first we need to prove that the y value of -2 is equal to 2. Oh, wait. Yeah, okay. We need to prove that the y value of -2 is equal to 2 in order for the Rolle's theorem to apply. And also, the Rolle's theorem, this equation... Okay, the video cut off what I was saying, but you have to use the Rolle's theorem for this problem, and the Rolle's theorem does apply because this equation is continuous on the closed interval and differentiable on the open interval. So first step is you have to find the intercepts, and the intercepts are when y is equal to 0. So you set this equation equal to 0. So you get 0 is equal to x squared minus 3x plus 2. And then you can factor, so 0 is equal to x minus 2 times x minus 1. So the intercepts are x equals 2 and x equals 1. Then you have to use implicit differentiation to show that f prime of x is equal to 0. So you use implicit differentiation by taking the derivative of both sides, and you get f prime of x is equal to 2x minus 3. And then you set this equal to 0 because you're trying to find the point at which the slope is 0. So 0 is equal to 2x minus 3, and then x is equal to 3 halves. Okay, so for the next problem, let f of x equal x to the 4th minus 2x squared, and find all values of c in the interval -2 to +2 such that f prime of c is equal to 0. So the first thing you have to do is find the y value of -2 and 2. So f of -2 is equal to -2 to the 4th minus 2x, 2 to the -2 to the squared. Sorry, I forgot to write that. And that's equal to 16 minus 8, which is equal to 8. So then f of 2 is equal to 2 to the 4th minus 2 times 2 squared, which is equal to 16 minus 8, which is equal to 8. Okay, so f of -2 is equal to f of 2. So the Rolle's theorem can apply because the y values are equal to each other. So then the next step is to use implicit differentiation on this equation. So dx of f of x is equal to d of x of x to the 4th minus 2x squared. F prime of x is equal to 4x to the 3rd minus 4x. Next, you need to set this equal to 0 because you're trying to find the c value where the derivative of the point in that interval is equal to 0. So 0 is equal to 4x to the third minus 4x. And then you factor. 0 is equal to 4x, x squared minus 1. 0 is equal to 4x times x minus 1, x plus 1. So x is equal to 1, -1, and 0. And these values are possible values for c, and they all fit in the interval -2 to 2. So these 3 points are our answer.